Hi, I'm going to try and keep this as short as possible, but I wanted to go over a couple of things that are going to be on your statistics and probability test that you're going to be taking on Thursday. Just like your other tests, there's 12 multiple choice questions and 2 short answers, so 14 questions total. First thing I want to look at is the probability formulas that you had. So just a quick review of theoretical probability versus experimental probability. Um, Theoretical probability is when we're talking about something that will happen or could happen. It's not something we've already done. It's theoretically, if we did an experiment, what would happen. Experimental is something that has already happened. So you've already done the experiment. So the experiment is done, it's over, and now we're looking at the data. The formulas are very similar. You can use a calculator whenever you're doing your test, and you're going to want one when you're doing this test because you're going to have fractions and decimals. I use this guy, you can use that. Again, I don't recommend using the calculator on your phone just because you can't use your phone on the final, so you want to get used to using a calculator and know how it works. So that's what you can use on your final. So theoretical probability, it's the probability in an event, number of favorable outcomes. Favorable is what you want to happen. Possible outcomes is just all the outcomes. And then experimental probability, it's a fraction of the number of times an event occurs over the number of trials that you had. So I'm going to do a quick example of each one of these. The first example for theoretical says if, anytime you see if, that's going to be theoretical because it hasn't happened yet. It would be if you did an experiment. So will it happen? So if you roll a dice twice, what is the theoretical probability that you will roll a 3 and then a 2? So I'm going to make a tree diagram of this. When you roll a dice, you can get a 1, 2, 3, 4, 5, or 6. And then if I roll it a second time, again, I can get 1, 2, 3, 4, 5, or 6. And I'm going to have that for each one of these. So I'm not going to roll out every single one, but the one that we want would be right here. Rolling a 3 followed by a 2. That's only going to happen once. So now we just have to figure out how many possible outcomes there are. So that would be the final stage of your tree. So this would be 6 plus 6 plus 6 plus 6 plus 6, or 6 times 6. There are 36 possible outcomes if I were to finish out that tree. So you could leave it as a fraction. If you're doing multiple choice and your answer options are decimals, you just type into your calculator 1 divided by 36. I'm going to get 0.027. So the probability is approximately 0.03 if I'm rounding. You might also see this written as 0.27 repeating. So it just kind of depends on the problem. But that's how you would do theoretical probability. What you want over all of the possibilities. Now, experimental probability, you want to make sure you read carefully. So this example says a quarter flipped 50 times. That's our number of trials. 22 of those times it lands on heads. What is the experimental probability the quarter landed on tails? So first of all, we need to do a little extra math here. So if it landed on heads 22 times, that means it landed on tails 50 minus 22. That would be 28 times it landed on tails. So number of times the event occurs, which would be 28, over the number of trials, which was 50. If I type that into my calculator, 28 divided by 50, you get 0.56. That would be our probability for that one. So if this were theoretical, it should be 1/2, right? Heads or tails, that would be 1 out of 2, or 50%, 0.5. But in this case, the experiment was done it was a little different. So experiment doesn't always match theoretical. Now, the last thing I want to finish up the video with is just a review of what your essay questions will look like and give you a couple of hints on those. This is very similar to a short answer question that you had on the very first quiz, 5.01. So that was the very last question. It gave you a graph and then asked you 2 questions. Your exam will ask you 4 questions. So it'll look something similar to this. So if you look carefully at this graph, we've got hours on the x-axis and temperature on the y-axis. Always look for those clues as to what's going on in your picture. So identify the intervals where the graph is increasing, decreasing, and constant. You are typing your answers in. So what I want you to do is you're going to type the word like increasing, and then you would tell me, when is this graph increasing? So if we look at our picture, increasing is when it's sloped upwards or sloping positive, and that is from 1 to 2. And then decreasing, again, you would just type out the word. And if you look at our graph, this is actually going down, and it changes the rate that it's going down, but it's still going down from 4 to 6. And then constant, that means it's not changing at all. That would be from 2 to 4. That's where it's flat, that's staying constant. Domain and range. Domain are your possible x values, and range is the possible y values. So the domain of this function goes from 1 to 6. There's different ways you can write that. I am just going to be looking for that you're showing me domain means x values 1 to 6. You could list out 1, 2, 3, 4, 5, 6, but technically because the lines are there, that means it's the spaces in between as well. Then you've also got the y values, and for this graph, the highest y value is 7. And the lowest value is 1. So the y values go from 1 to 7. You can also write this using 1 is less than or equal to y, which is less than or equal to 7. It's kind of hard to do those symbols when you're typing, so it's okay to just use the dash. I will accept that answer. Does this represent a function? Yes, even though it's up and down, there's exactly 1 x for every y, 1 y for every x. And then detailed description, tell me what's happening. So this is hours and temperature. So you could say at 1 p.m., the temperature starts at 4 degrees. You could say you're in Antarctica or somewhere really cold, and then maybe the sun comes out and it's going up. Then it kind of stays the same for a couple of hours. Maybe some clouds come out or it gets windy and the temperature goes down. So that would be your explanation there. The last essay question that you're going to have is going to give you a table and ask you some questions about that table. This is very similar to the third quiz you took, 5.03. There were some questions that looked a lot like this on there. This is not the exact question you're going to have. These questions are the same, but your table is going to look different. So first question says scatter plot or line graph. Line graph is if you're having like temperature or price or something that you can have like decimal or fractions. Scatter plot is when it's like exact things. So for this one, we're looking at ice cream cones. That is an exact thing. You're not going to be selling half an ice cream cone or a fourth of an ice cream cone. You're selling whole ice cream cones. So this is going to be a scatter plot. And that would be your reasoning. You would say you're selling whole ice cream cones, so it needs to be a scatter plot. Some of you on the quiz did not really get that part. And that's okay. I want you to know it for the exam. That's why I'm telling you that in this video. Again, if your Y value is something that can change and have fractions and decimals like temperature, it can be 62.5 degrees. That would be a line graph where you would connect the dots. Now, if you wanted to add an outlier to this, like let's say I put in here maybe at 56 degrees, they sold 70 ice cream cones. That's going to be an outlier. That does not match the rest of the data at all, nor does it really make sense. So describe the data point and what it represents. You could say maybe a birthday party showed up at this store and there were a ton of kids and families, and even though it was cold, they sold 70 ice cream cones. So just try and think of something that could make sense for whatever your outlier is. And then describe the type and degree of association between the age. This one is not going to be diaper changes. This would be ice cream cones and temperature. So obviously, as the temperature goes up, ice cream cones sold also goes up. It's a strong correlation, strong association. And I would say this is positive. They're both going up. As temperature increases, sales increase. I'm backwards, so that would be that way for you guys. So strong correlation, strong degree of association, and it's positive, right? So that would be your type and degree. All right. Some of you on your quiz just gave me definitions. I love that you're looking up your answers and trying to find some resources, but I want you to write things in your own word and it has to fit for the problem. So when I'm grading, I'm going to be looking for, does your answer match or is it just a definition? It's got to make sense for the problem. All right. Good luck. Email me if you've got any questions. Thanks for watching.